Good morning, all. Am I audible? Am I audible?
Yes, ma'am.
Yeah. So we will begin. Good morning, all. We will begin with the yesterday's class question assignment that I had given, and then we will begin with Qs. Okay. Um, just 1 minute. Yes. Can anybody share with me the program on GCD of two numbers? Finding GCD of two numbers. Can anybody share with me? Okay. Anyone has done? You can just comment. Anyone has done? Okay, I will show you two alternatives of find. Okay, all of you have done. Very good. Now, let me just share with you uh, two alternatives of finding GCD of two numbers using recursion. Okay. This is one alternative where multiple time mod operation is useful. So I think this you have done in mathematics many a times. Okay, you have called a GCD on the two numbers. It returns the final GCD of the two numbers. So if b is 0, return a. Otherwise, go ahead with calling of the function GCD on n comma m mod n. Okay, I think this is more oftenly you have done. Manually also you have done. Okay, anyone has applied this kind of technique? Please let me know. Anyone has applied this technique? If yes, just tell yes. If different technique, then almost same. Okay, almost same. Fine. Now I'll show you one more alternative. I hope this is clear for you. It's a very simple question, simple way of doing it. Um, I'll just show you one more alternative. Finding GCD of two numbers using recursion. Okay, just see here. If m is 0, return n. If n is 0, return m. If both are equal, return m. If m greater than n, then call the GCD on m minus n, comma n. N remains as it is. You are subtracting n from m. So m varies. If m is less than n, that is n greater than m, then call the GCD on m remains as it is. N becomes n minus m. Okay. How this works? It is without using mod operation. Okay. Similarly, similar to the previous example, I have called a GCD function on m and n and printed the value that it returns. Okay. Anyone has tried this kind of technique? If yes, please comment yes. I'll just go up. You can just have a look at the function that is written. Okay. How this works? You want me to explain it, or you can trace it on your own? Let me know. You want me to explain it? Please let me know. Okay, I have to explain this. Let us take a very simple example of 24 and 14. Okay, let us take 24 and 14. For when I'm trying to explain this, please have a pen and paper with you. Only then you will understand it. Okay. I have m value as 24. M is equal to 24. N is equal to 14. Okay. So m is equal to 14. M is equal to 24. N is equal to 14. Then I'll enter inside. M0, no. It enters into the second if. N is 0, no. Is m equal to n? No. So it goes into else part. In this case, m is 24, n is 14. So 24 greater than 14. It is true. Okay. At this point, it enters and calls a GCD on. Calls GCD on 24 minus 14, that is 10, comma 14 remains as it is. 10 comma 14. So there was a call on GCD of 24 comma 14. Now this has called a function GCD of 10 comma 14. Okay, so a fresh GCD function is called with m value 10, n value 14. Now both m and n are not 0, m and n are not equal, so it goes into else if. M is 10, n is 14, 10 greater than 14 fails, so it goes into else part. Now at this point, it calls GCD of m remains as it is, and n becomes 14 minus 10, that is 4. So a fresh third time GCD is called. GCD now enters with m value 10, n value 4. Okay, both are not equal, goes into else if. 10 greater than 4, true. Okay, so now it calls GCD of m minus n. 10 minus 4 is 6, comma n remains 4 only. Okay, there's a call for GCD of 6 comma 4. It enters again else if. So this calls again GCD of 6 minus 4 is 2, comma 4 remains as it is. Okay, now this GCD again calls, see I need not explain it again, it again calls me GCD of 2 remains as it is, 4 becomes 4 minus 2, that is 2. GCD of 2 comma 2. GCD of 2 comma 4 calls again GCD of 2 comma 2. Okay, why 2 it is? Because n minus m. N is 4, m is 2. 4 minus 2, it is 2. Until m and n become equal, this continues. Okay, now GCD of 2 comma 2 enters with a value m is equal to 2, n is equal to 2. M, n both are not 0. So m is equal to n, it is true, because 2 equal to 2, it is true. So what it returns? It returns 2. This function call has returned 2 to this. Now this gets replaced with 2. It gets replaced with 2. And this 2 gets returned to here. Okay, this 2 gets returned to here. This 2 returns to here. So the value returned is 2. Where the value returned is 2 and it is returned to me. Okay, GCD of 24 and 14 is 2. This is how the things work here. So the GCD will stop either when I get both numbers m and n are equal, means either of them are the GCDs, or m becomes 0 or n becomes 0. Only then the GCD function stops. without going for mod operation, without going for division, I am doing multiple times subtraction. Okay, so without using mod or division operation, can I find the GCD of two numbers? This is how I can find it. Any doubt here? Any doubt here? You can take any example. Okay, this works like this only. If no doubts, I'll proceed ahead. Can I proceed ahead? Yes, thank you. Now, have you tried the other examples? Have you tried the other examples? I had given 3 examples yesterday. 3 programs I had given. Have you tried all of them? Comment yes if you are tried. Or you have any kind of doubt in any of the program. Okay. I will then proceed ahead to what is called as queues. Yes, guys. Now I am talking about what is called as queue data structure. Okay. Let me just show you this diagram first, and then I will go to the next presentation. What is this queue I am talking about? Guys, I have started with the 3rd chapter of the syllabus, that is queue data structure. For your information, this is one more kind of data structure or one more way of arranging the data. The way in which I am arranging the data as compared to stack. Okay, when I compare this data structure with the stack data structure, stack talks about only one end is open enough for you to either have the accessibility of the elements, or you want to add the elements, or you want to delete the elements. Whatever you want to do, you are doing all those things from only one end, one and only one end. The other end of the array is seized. Okay, the other end of the array is seized. It means what? All the operations are taken care at only one end. And since it is happening from only one end, I used to call that data structure as LIFO architecture, because last in first out. The element that is entering at the last will be the first one to exit. But now when I compare that with, this is an alternative. A few modification or a bit of modification is done to the array, then I name it differently. I name it differently. This different name has come to the queue because I have the way in which I have both the ends of the array available as open. Okay, I will keep both the ends of the array as open. When I keep both the ends as open, when I'm talking about open ends on both the sides, can I have all the operations happening from both the ends? It may not be true always. Okay. When I want to restrict, having the restriction on what operation need to be carried on what end, then I call it as input restricted queue or output restricted queue. Okay, this kind of data structure where both the ends are open with the restriction that you have to add the new elements from the back end of the queue and you have to delete the elements from the front end of the queue, then that kind of data structure is called as a linear queue or a simple queue. A queue data structure talks in such a manner that any element that is getting added, that new element is added from the back end of the queue. It is added from the back end of the queue. And when you are deleting the element, it has to be deleted from the front end of the queue. This is what is a queue data structure. And when I tell it has to happen from the back end, that back end is, in technically, it is termed as a rear end of the queue. See, this you can compare with the normal queue that you have. When you are in a queue to get movie tickets, how do you add on? Do you add from the front? Or the person who is ahead in the queue, that person will come back and then take the tickets? Or the first person who is standing in front of the queue will get the first ticket, and that person will be moving out of the queue. The first person to be moving out of the queue is the first person who is standing. Okay, so queue data structure talks about like this. If you want to add any new element, add the new element from the back side, that is rear end. Whoever is getting added doesn't matter for that. But when you are trying to delete the elements, you have to delete from the front end of the queue. Okay, this back end is called as, it is called as rear end of the queue. Okay, let me unlock the meeting and then come back. Yeah. Now, when I tell it is front end and rear, the front and rear will decide the name of the queue. Okay, and the kind of operation, please ensure that whatever words I'm using, please pay attention towards that. The kind of operation, when I am adding new element, it is adding new element. I call it as insertion from the rear end of the queue. Okay, insert is the first operation that I'm speaking about in the queue data structure. That insertion is also termed as, more technically, it is also termed as what is called as NQ. It is termed as NQ. And when I delete the element from the front end, I call it as delete operation from the queue. And that more technically is termed as DQ. DEQUEUE. Okay, so when I ask you the different operations on queue, simple queue, I call it as NQ and DQ. NQ talks about adding the new element from the rear end of the queue. DQ talks about deleting the element, existing element from the front end of the queue. Okay, these two are the basic operations of queue data structure. And since the first person who has get in, the first person, look at this person is the first person who has entered, who is at the front of the queue. The first person is the first one to go out. That's why the data structure, queue data structure, is also called as FIFO data structure. It is termed as first in, first out. Okay, any doubt in the introduction of queues? Please let me know. Any doubt? No. Okay. So I can very well go ahead with the other explanation part. Now, just 1 minute. Just 1 minute. I'm not getting the pen to mark the things. Just 1 minute. I'll stop sharing and share back. Okay. Yes, now I'll share the screen. Yeah. You can see over here, there are many people standing in the queue, and this person has got, suppose they are standing in the bank, okay, ATM, they are waiting, people are waiting. This person is the first person to get the money and go out of the queue. So this is called the front end, and the people are getting added. This is called as the rear end. When you talk about stack, how many ends are there and what is the name of that end? Can you comment? When you take stack, what is the name of the end? What do you call that? Top. I used to call it as a top end of the queue because I'm talking about only one end of the array. But when I take a queue, queue talks about two ends, and the two ends are called as front and the other is called as a rear. Then if you see this kind of arrangement, and when I apply array on that, when I want to implement this data structure using the array, what may be the condition to tell that queue is right now full? What may be the condition to tell that queue right now is empty? Can you think and tell me? Suppose that queue data structure is having an array of size, say let's suppose we have an array of size 5. Okay, this is 0, 1, 2, 3 and 4. This is the array available which is acting as a queue now. Okay, now if you want to add any elements, you will add from this end, rear end. If you want to delete, you will delete from this end. Okay, so what can be the condition for telling that queue is overflowing? What may be the condition for telling that queue is underflowing? Can you comment? You can think about it. It may be correct, may not be correct. Sneha has commented, when rear is equal to 4, there is an overflow. Correct. When can you tell that it is underflow? When front is 0 for the queue is empty. Okay. Let's suppose I insert 10. Okay, first of all, what is the initial condition for front and rear? Okay, what is the initial condition for front and rear? Let me let's suppose, let's suppose I have a queue like this, okay, and it has 4 elements. It has 4 element positions. So this is 0th position, this is first position, second and third. Okay, now assume that I do not have any elements in the queue. I don't have any elements in the queue. So where should be my front and where should be my rear? Guys, if you answer to these questions, no, you can write the queue implementation on your own. That's why I'm asking these questions. What should be the value of front? What should be the value of rear? Front and rear are 0. Praveen has commented front and rear are 0. Sneha has commented -1. Whether both front and rear are -1, or is it that only rear is -1? Because you have 2 pointers here. Unlike the top. Okay. Both front and rear are -1. Let's assume both front and rear are -1. Okay. Praveen, I'll come back to your answer and I'll clarify why it cannot be 0. Okay. Let's suppose both front and rear are equal to -1. Okay. Now, if I want to have the first ever insertion done, from what end the new element has to be added? Comment quickly. You have to be active enough for this. Okay. From what end the new element has to be added? Rear. Correct. From the rear end. Okay. I call it as REAR. Okay. REAR is different. REAR is different. Okay. So rear end, you are supposed to add the new element, and when you want to delete the new element, delete an existing element, from the front end you are supposed to delete. Okay. Now I will talk about only the insertion. When I want to add a new element, I have to add from the rear end. It means that before I can insert the new element, I have to increment the rear, similar to the thing that you have done in the stack. In the stack, what we had done, first we had incremented top, then assigned the value. Correct? Similarly, as we had done with the top in stack, I will do the same thing with the rear. What is that I'm doing? I will increment rear first, then assign the value. So how I can do that? I can do that in this manner. I can do that in this manner. What I will do? I'll write rear plus plus. Sorry about the kind of writing that I'm doing, but if you understand, that is more than sufficient for me. So first thing that I will do is I will increment the rear. After I increment the rear, what will be the value of rear? Quickly comment. 0. Value of rear will be 0, correct? So I will increment the rear and then I will assign the element, the new element that I want to add. So where it gets pushed, where it gets inserted at the rear end. Let's suppose I have inserted the value 100. Value 100. So it will come and sit in the rear position. And where rear will be pointing? Rear will be pointing to 0. Rear will be pointing to 0. Where front is there? Still -1. Okay. Now what I will do? I will insert one more time. First thing that I will do is increment rear, then assign the value. So what will be the rear value if I increment now? 1. What will be the front value? Front value. No, it is -1. Front value is -1 because we have assumed initially that both front and rear are pointing to -1. Okay. Now, accordingly, 200 will be sitting inside position 1. Okay. Now let's suppose I have deleted an element. I have deleted an element. What is the way in which I can start deletion? From where I have to start the deletion? Sneha, can you comment? Yes, you have commented that I have to start deletion from 0. But do I have any explicit accessibility to the front? Do I have any explicit accessibility to the front end of the queue? What is front value going on? Front value is -1. Whether front right now, is it working on the active array? No, it is somewhere else. Okay, this is the reason why I should have the front value equal to 0 and rear value is equal to -1. So what will be the initial values of front and rear? Front is 0, rear is -1. Please write it down. Please write it down. What is the initial value of front? Front has to be 0. Why? Because this is the point from where I have to start deletion. Front can be 0 at the beginning only because it never comes into picture whenever I want to insert any new element. Okay, then accordingly, what are the initial values of front and rear? Let me comment it. Front is 0, rear is -1. These are the initial values for any queue implementation. Whether this is clear for you? Whether this is clear for you? Comment quickly. Yes. So, accordingly, I will start afresh the insertion operation. Okay, I'll start afresh. Assume that, let me end this and restart again because, okay. Now, let's suppose I have a queue of size 4, the same queue I'll take, okay. The size of queue is 4. This is 0th position. First position, second, third. Now, I just want to insert the first ever element. Where is front? Where is rear? Quickly. Where is front? Where is rear? Empty queue. Where is front? Where is rear? Front 0, rear -1. Correct. Front is 0, rear is -1. So first thing I want to do is insert the first ever element. So 100, if I want to insert, where it has to sit? It has to sit in the 0th position. So am I disturbing front? I will not be disturbing front. Whenever insertion operation is there, I will never touch upon front. Who is the person who is helping me around? The rear. Okay. So what I will do, I'll increment the rear. I'll not touch upon the front. So who is getting modified? Who is getting modified in the insert operation? Only the rear. Front will never be modified. Okay. Then I will increment rear and then I will assign the value to A of 0. That is A of rear. Then where is front? Where is rear at this point? Quick. Where is front? Where is rear? After I insert one element. Both at 0. All of you are right. Front is 0. Rear is also 0. Let's suppose I will continue insertion. Okay. Let's suppose I'll continue insertion. I want to insert 200. So rear gets incremented. Front will be at 0 itself. Rear becomes 1. Let's suppose I want to insert one more element, 300. After I insert 300, where will be front, where will be rear? Front will be at 0, intact, unchanged, and rear will be at 2. Okay. At this point, I will call delete operations. I will call delete operations. When I want to delete 100, if I want to delete 100, I have to, when I call delete operation on queue, the element to be deleted is 100 because the property of the queue tells like this. Whenever you want to delete, you go for the front of the queue and delete the element. Okay. So it definitely has to delete the element which is ahead of the queue. Who is in front of the queue? 100. And 100 is at position 0. What is this position? 0 is the position of front. Now, when I want to delete 100 I want to make front to point to 200 instead of 100. What is that actually I'm doing? What is that actually I'm doing? After I delete 100, front will be pointing to 1. And it means what? Front will be pointing to 200. Okay, it means what? I have to increment front. After every deletion operation, rear remains intact, front getting incremented. Front getting incremented. Okay, in this case, 100 gets deleted. It means what? Front is now pointing to 1, rear remains intact on 2. Now, if I want to delete 200, what is that I need to do? Increment front again. So, front comes to 1, front comes to 2, rear is already at position 2. Praveen, when I come back to your answer, front is equal to 0, rear is equal to 0. When both front and rear are equal, it means that there is exactly one element in the queue. The meaning of front is equal to 2, rear is equal to 2. It means what? There is exactly one element in the queue at position 2. Okay. So if front is 0, rear is 0, what is the meaning of that? Front 0, rear 0 means there is exactly one element at position 0. Whenever both front and rear are equal, it means that there is exactly one element in the queue. Whether Praveen, it is clear. That's why the initial values cannot be zeros. Is this clear, Praveen? Yeah. Okay. Now, when I delete 200, front and rear both are at 2. Okay. Can anybody comment at this point? Can anybody comment at this point? When can I tell that queue is empty or queue is underflowing? Can you guess upon this? When queue becomes empty? When I delete 300 also. Okay. But when you delete 300, there has to be some change to the front. Okay. Yes, you are right. Whenever front is greater than the rear, whenever front is greater than the rear or rear is smaller than the front, initial value of front and rear, you just think about it. Initial value of front is 0, rear is -1. There also rear is lesser than front. So whenever Q is empty or Q underflowing, front is always greater than rear. So if front greater than rear, then I will tell Q is underflowing. If rear is equal to the size -1, then I will tell that Q is overflowing. Can I just write it down? Can you just write it down? If I write if rear is equal to the size -1, then what I will call? I'll call it as overflow. I've commented in the chat. You can just check. Okay. If at any point in time front becomes greater than rear, I call it as underflow. So these are the conditions for insertion and deletion. Whenever you want to insert, check for the overflow condition. Whenever you want to delete, check for the underflow condition. And whenever you want to display, front greater than rear becomes the empty condition for the normal Q. Is this clear or you have any doubt? Is this clear? Or you have any doubt? Clear. Okay. Okay. I have just shown the same thing in the array implementation, how it will be done. Just have a look at it. 4, 8, 6 are inserted. So where will be front, where will be rear? Can you comment? Where will be front, where will be rear? If I have 4, 8, 6 are as the inserted elements. Front 0, what about rear? Front 0, rear is 2, correct. Now, if I delete this, if I delete one element, if I delete one element, front 1, rear 2, okay? Yes. Now, if I insert one more element, front 1, rear 3, okay? So this is how you have to analyze. This is how you have to analyze the total behavior of the ordinary queue. Now, in this case, why normally ordinary queue is not preferred? That to array implementation of ordinary queue. Why it is not preferred? Guys, you just check out. There are 3 elements available which are feasible elements available. Okay. But actually, what is the size of the queue over here? What is the size of the queue? Totally, there are 6 element positions. But among them, how many I have added? 3 elements I have added. In this case, these 3 element positions are empty. They are blank. Now, after I have reached this position, if I try to delete this element, what will be front? Front will come here. Rear remains at 5. Front is 4, rear is 5. Now if I delete this, front and rear both are 5. Now if I try to insert a new element, can I do that? Now if I try to insert a new element, can I do that? Comment quickly. Why I can't insert any more element? Because rear is already pointing to size -1. So though 5 positions are still free for me, it tells me queue overflow. This is the drawback of ordinary queue. Then how can I negotiate this kind of situation? I can negotiate this kind of situation by altering a bit of working of this ordinary queue. That we will see in the next class, not now. Have you understood this much or any doubt you have? Have you understood this much or you have any doubt? I hope you have understood this. Okay, we will begin with the next class with the implementation of this ordinary queue. Then we will see the drawback of this and how I can go ahead without using the ordinary queue, or how I can modify a bit of it so that even the insertion can be continued when there is a place for such a new element. Okay. So there is a comment from Praveen. Since these data structures are also basically arrays, do they also end with zero or null character? Obviously, they will end with zeros. If you take integer, if you take character, they will end with null character. Obviously, okay. So since ordinary queue has a drawback, there is a new kind of queue or alternative of queue that is called as circular queue. Okay, we will see about that in the next class. Next class, first thing we will have the implementation of this program. Then we will go ahead with the other kinds of queues. Okay. Thank you all guys, and enjoy your holidays. Happy Diwali. Have a nice time. Okay. Have a nice festival time, but be safe when you are celebrating Diwali. Okay. So Diwali will get you a lot of happiness and a lot of knowledge. Okay. So please pray God that you are getting much more knowledge in the coming days. Okay. Happy Diwali guys, and enjoy. Thank you all.